In a previous video, we discussed why this proposition and proof are both correct and why the answer would be A. And then in the video after that, we discussed why this one is incorrect, and that was because of part 5. So you might want to watch that video if you haven't watched it already. Now we'll look at another, this exact same proposition, but another proof that is wrong for a different reason. So when you look there, so reading through this, let's see. Assume that x is an arbitrary odd positive integer and y is an arbitrary odd positive integer. Okay, that's stating the assumptions, that's correct. So x is equal to 2n plus 1 and y is equal to 2n plus 1. There's the issue. All right, so the issue is in that line right there. And here we didn't quantify the variables. So what we should say here, comma, I guess that's not a very good comma. What we should say here is for integers n and m. There's many different ways you could say that. You could say for where n is an arbitrary positive integer and m is an arbitrary positive integer. But that's really saying the same thing. It's just saying for integers n and m. So one of the things that bothers students with proofs a lot is that they say, well, how do I know it's correct? What is a correct proof? That's a really great question. All right, so the answer to that is going to be very long-winded, and I might not really go into it. But a truly correct proof of even this proposition here, like the one you saw in 4 above. Maybe I should go back to that real fast. So this proposition is true and the proof is correct. So the real version of this correct proof, written in a checkable way with all symbolic logic, would be pages upon pages long. And so really, if you want to get into the nitty-gritty details, none of the proofs that are written in the Zybook are absolutely correct. They are shorthand versions of correct proofs. And the idea is that you could turn this into a mathematically verifiable proof, like an equation. And there are ways to do this. And there are even programs that do this and check proofs and stuff like that. It's an active field of mathematical research. But so what is a correct proof? A correct proof is a proof that meets all of the criteria that are discussed in part B. And I know that in part B here we're saying that these things haven't happened, but maybe the negation of those meets those criteria. So all the assumptions are stated, all variables are defined, all the math is correct. Let's see what else. Correct rules of logic are used, and each line follows from the one before. Okay. That's pretty long-winded already. So what is a correct proof? A correct proof is a proof where you state all of the assumptions, all of the variables are defined, all of the mathematical equations are correct, correct logic is used, And each line follows from the one that came before it. All right, so back to the task at hand now. So in this one, you see that the variables were not clearly defined. And so in this problem, the answer would be the proposition is true, but the proof is incorrect. And why? Not all variables have been defined.